fucking a long time ago.
We started 4-2.
Okay. 4-3, we're talking about logarithms. What do y'all know about logarithms?
It's a log
That they start to
with a rhythm.
Okay.
You're funny, I know.
I mean, hey, it's a log.
It's so funny, I forgot that.
I don't know, but it's.
What year?
I mean, all laughing.
We ready? I don't want to talk over you. So if we look at the calculator, we just talk about some basic things real quick. What's the inverse of adding?
Subtracting.
Inverse of adding and subtracting. You notice on the calculator, those buttons are really close to each other, right? What is the inverse of multiplying?
Dividing.
And they're right next to each other. And what's the inverse of on?
Off.
Okay, it's the same button. Pretty cool, huh?
That's fine.
Calculator is set up with inverses. Last week, I believe we talked about exponential functions, right?
Yes.
Exponential functions means the exponent contains the variable. Look at your calculator. Right over here, I see two buttons that have the x as the exponent, and they're exponential. Look at the button they're tied to. So specifically, if we're talking about 10 to the x, that's exponential. What is the inverse of 10 to the x?
X.
Is it
Log. Okay? So what we're doing is we're doing logarithms, which are inverses to exponential. That's what we're doing. Okay? What do y'all know about the graphs of inverse functions? You're breathing. Quick Googling graph.
I was looking up cricket noises.
What must be true for a function to have an inverse?
Variable.
Well, you gotta test and see how this goes, because y'all should know the answers to this. There's something that must be true in order for a function to have an inverse.
Say it again.
What must be true for a function to have an inverse?
Negative. Or negative. No, it's not that.
It has to be a function.
Do all functions have inverses?
Yes. No.
No.
No. Why?
Because the x values repeat.
Oh, it has to be a 1-to-1? Nope. I don't know.
Okay,
You're welcome.
so for a function to have an inverse, it must be 1-to-1.
Yes.
True?
Yes.
Okay. If you were to graph a function and its inverse on the same coordinate plane, what will you notice?
Very difficult.
Nothing. Nope.
Probably, for some of you, that's true. What should you notice?
Something.
They only cross one.
They never touch
They
it.
can.
They never.
Wait, what?
They can touch.
Did they meet the zeros? Just kidding. The x-axis? Nope. I'm gonna stop guessing.
They can. They can cross. They can cross. Huh? Oh, there's a reflection involved. Yes. A reflection across what?
The X or Y axis.
Neither.
Quadrant.
A reflection across what?
The
Axis of symmetry.
no, each other.
Duh.
Each other's lines.
Hence the definition, huh?
Each other's lines. I don't know. Like this is like off each other.
It's a reflection off of the.
Vertex.
So inverses are reflections across something.
Inverses are a
This is
reflection.
embarrassing.
Tyler, you don't even know what some.
Cause I'm not spitting random answers, just doesn't mean we're in the same boat. Right now it's sinking.
reflects.
Pretty cool.
Summer, do you know it?
Why?
Anna knows, I think. I don't know. I think it, is it asymptote?
Is it the Y? Did somebody already say that?
I forgot the question.
Are you sure? It doesn't,
Yeah.
it doesn't reflect. How about it doesn't reflect?
If you graph a function and its inverse, they are symmetric about what line?
The vertex.
X squared enter. I don't know. That would be X.
Well, yeah, but what is that axis, what is the equation of that axis of symmetry? That's what I wanna know.
0, 0.
That's a point, sir.
Oh, yeah.
Y'all act like we've
X
never talked
equals-
about this before. I'm glad I'm recording this
Oh,
moment of genius,
wow.
sixth period.
It says, I don't know. I was saying, I don't speak English.
You said waffle.
I don't know. Can we get a hint?
Yeah,
Huh?
can we
We
get
get
it?
hints?
Is it the X? Does that have to be something with that?
No, because it's not X or Y.
Okay, we'll just move on.
No,
No,
you can't do that.
It's just a hint.
You're a
Use an
teacher, you're
intersection.
supposed to
Okay.
teach us the stuff that we don't know.
Can you use it in
It'll
a
come up.
sentence?
I was
No.
wanting to see if y'all can get there before it came up to get there.
Okay, wait,
We
try one more
can.
time.
We just need a little.
Try one more
Shove
time.
off the
Just
cliff.
one hint.
Try one more time.
Yes, they reflect across the axis of symmetry. And what's the equation of that line?
X equals
Yeah.
whatever your number is.
Okay, so we'll be talking about logarithms. We'll be talking about logarithm equations. We'll talk about logarithmic functions. And we'll be talking about the properties of logarithms. Yay. A logarithm is written y equals, and there's multiple ways of reading this. I could read this the log of x base a, or I could read this the log base a of x. Okay? I'll read it two different ways. Just depends on how it comes out of my mouth at that particular time. I do want to point out that y has to be a real number, so we're not dealing with imaginary numbers, which is a good thing. Okay? And I do want to point out something else that's very, very important, and that is the fact that a and x are both positive. Okay? A cannot be negative, x cannot be negative. Can't happen. A and x must be positive, but a can't be 1. A can be any positive number except 1. Okay? I like to use highly technical vocabulary, and so you might use this to remind yourself of what things mean. If I wanted to convert a logarithm to exponential, okay? That's the log. This is the base. So notice that the a is the base, right? And on the base we have the power over here, or the exponent. And right here, where this x is, I have something. Okay, I've got a thing. So log, so I've got base to the power equals the thing. And I'll say that a lot. Base to the power equals the thing. If I have a logarithm, the base to the power equals the thing. A to the y equals x. And that's what it says right here, isn't it? A to the y equals x. Base to the power equals the thing. And I normally write it this way instead of putting the y first. That's just how I do it. Next slide here. What we're going to do is we're going to practice taking a logarithmic function or logarithmic form and turning it into exponential form, or exponential to logarithmic. Okay? We're just going to go back and forth a couple times. The first one is done for us. The log of 8 base 2 is equal to 3. What's the base?
2.
2. What's the power? 3. What's the thing? 8. 2 to the third equals 8. Okay? So, for first example, log of 16 base 1/2 is equal to negative 4. What is the base? What is the power?
Negative 4.
equals the thing, which is,
Equals 16.
and that's all there is to it. Okay? Now we're gonna go the other direction. In exponential form, I have 10 to the 5th power is equal to 100,000. I want to convert that to logarithm.
Log 10.
Log.
10.
What's the base?
10.
10.
All right, I'm gonna change colors for just a minute, and I'll tell you why in just a second. Put my 10 right there. All right. What's the power?
100,000.
100,000.
No, that's the thing.
Oh, wait, 5.
What's the power?
Oh, yeah. 5.
And what's the thing?
100,000.
100,000.
Do we have to go in that order?
No,
That kind of bothers me.
no, it doesn't. I'm just trying to be a little consistent.
Okay.
Now I'm going to talk about the fact that I wrote the 10 in a different color. And there's a reason behind that. So let me talk about some other stuff real quick. That's an X. Does that X have a coefficient in front of it?
No.
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 Or yes.
Yes, it does. And what is that coefficient?
1.
But we don't write it, do we?
No.
Does everyone agree and accept the fact that there is a 1 in front of the X?
Yes.
There's also an exponent on that X. What is the exponent on that X?
1.
1. If it was a 0, then I would have written 1. Okay, there's a 1 right here, right? Does everyone accept the fact that if there's an X there, there has to be an exponent of 1?
Yes.
We just accept it. Okay? What is that?
Square root.
A square root. Is there a number up there?
No.
Yes.
2.
Where's a 2?
Two's on the
on
like
top.
10, I don't know what that thing is called. Above the V.
Right here?
Yes.
That's called the
The N.
index. So we all accept the fact that if you see this symbol, if there's not a number written there, we all accept the fact that that's a 2.
Yes.
Okay, y'all with me? Logarithms are kind of the same. If there is no number here, guess what we assume it is?
1. Wait, what?
If there is no number here, we will assume it's base 10. This 2
Oh.
is log base 2.
Because it's in.
This is log base 1/2. This is log base 10, but I'm not gonna write the 10.
You would just write log 100,000.
Log 100,000, done. If there's not a number there, we accept that it's base 10. Look at your calculator.
That's what it means by it's not. It can't be 1, right?
Yeah, B10X.
Yeah, it can't be 1. Yeah, on your calculator, you have 10 to the x power. The base is 10. If you press the log button on your calculator, do you see any base if you hit the log button?
No.
If I want to find out what is the log of 100,000, there's no base. What is the base?
10.
10. Okay? And log base 10 of 100,000 is 5. Okay? So again, that's why I wrote it in a different color. Is it wrong to write it?
No.
No, it's not wrong. Guys, I'm not going to write it. Okay? Only time I'm going to write a base is if it's not a 10. Then I'll write the base. Okay, next one. Log.
Log.
Base.
3. Oh.
3. Thing.
1 over 81.
Power.
Negative 4.
Oh, yeah, negative 4.
Next one. Base.
5.
5.
Power.
1.
1.
Equals the thing.
5.
5.
Okay.
Do we have to write the 1?
The only reason we're writing it there is because we're actually translating from this to this.
Okay.
Okay, it's to show that yes, we do know that that power is 1. And the last one.
3/4. 0.
To the 0 power is?
Yes, equals 1.
And any number to the 0 power is 1, right?
Yes.
Questions?
Somebody at your door.
What?
Mine always haven't been listening to that. I thought it was just mine. But
Have you cleared your cache?
I keep redoing it and then letting them off and then signing off and then.
You might want to contact Alamo College. Try them. clear all cache from all history from the birth of Jesus, maybe before that even. And then turn it off, close everything, and turn it back on.
I can't wait to watch this recording.
Again, we should make a highlights video.
Oh my gosh, can I?
Outtakes. Alright, we're gonna solve. I wanna know the value of x. What is the base of this?
It is.
Okay, so if we were to rewrite this from logarithmic form to exponential form, base,
3.
Are you okay?
Oh my, X.
Yeah.
base is x,
Yes.
power is
3.
3, the thing is,
827.
okay? I wanna get x by itself, how do I undo a cube?
You screw.
You take the cube root, I will take the cube root of both sides. The cube root of x cubed, x. Okay, this next step, I'm gonna write this down. I don't expect you to write this down, but this is just a reminder to you. If I take the cube root of a fraction, that's the same thing as the cube root of the numerator divided by the cube root of the denominator. Again, writing that step down is not important. You don't have to do that. I'm just doing that for you as a reminder of what a cube root of a fraction really is.
Wait, I'm confused how we got that.
From where?
Like, how did you? I understand my funny. How did you get the uppy thing? This thing.
The screen.
I wanted to get rid of a cube. The opposite of cube is cube root.
But how did you get x to the third equals?
Base, power, equals a thing. We just did a bunch of them. Hasn't
What's
changed.
different?
I actually like this. It's pretty good.
Okay. What is the cube root of 8?
It's pretty
2. Because 2 times 2 times 2 is 8. What is the cube root of 27?
3.
Because 3 times 3 times 3 is 27. And in reality, we should go back, plug this in the very beginning, and check it to make sure it's right. Okay? I'm not going to spend any time checking problems until I know for sure that it's not that way. I don't want to waste time doing all the checks. Okay. Questions on this one? Next problem. Since one particular student struggled on the last one as far as what the heck just happened, she will tell me what to write down. What's the base?
4.
What's the power?
X. I mean 5 over 2.
Equals the thing, which is,
X.
okay. That's what we did on the last problem. Now, I want x by itself. I did.
That's it.
What is 4 and 5 have even mean?
That it's
4 is third, 4.
Okay. Yeah, remember when you have a fractional exponent, there's two things going on. The top number is the power. The bottom number is the index. Right? Okay, so I could write this, please stop. I could write this as the square root of 4 to the 5th power. That's what it means, right? My index is 2, my power is 5, is equal to x. Or, I guess, if you really wanted to, you could have done the square root of 4 to the 5th power. Anybody want to do 4 to the 5th power for me real quick?
no.
Yeah, I don't either. Okay, 4 to the 5th power is like,
16 times
that's 256 times 4,
It's 32.
1,024, 32,000?
Yeah.
Yeah, 32,000, yeah,
Oh.
I'm not doing that.
I thought you said 32 is 4 to the 5th power.
Okay, square root of 4?
2.
2 to the 5th power is x, and 2 to the 5th power is?
32.
Hannah, you good?
Yeah.
Next problem. Got ugly all of a sudden, didn't it?
Yes. Very.
Can you think? Never mind.
How do you eat an elephant?
You don't.
One bite at a time, right? So I don't care how ugly the problem is, let's just do what we know. What's the base?
49.
What's the power?
X.
Equals the thing,
7 to the 3rd index.
the cubed root of
Cube.
7,
That's the same thing.
okay? Well, now what?
Wait a minute.
There was a property that we talked about that said if a to the m is equal to a to the n, if that's true, the bases are the same, what must also be true? Okay, so, can you write the number 49 as a base to a power?
Yes.
Yes.
49 can be written as
7.
squared.
7 squared.
Does anybody object to that? So 49 and 7 squared are the same, right?
Yes.
So I can replace 49 with 7 squared and go ahead and put that x on there. Can you write the cube root of 7 as a base of 7 raised to a power?
Yes.
7 to the 1/3. Because that's what an index is. The index is that bottom number. Okay. What does 7 squared to the x power? What do you do when you raise a power to a power? So that means I have 7 to the 2x power. Again, this would be an unnecessary step. Is equal to 7 to the 1/3. My bases are now the same. Because my bases are the same, do I care about the 7?
No.
No.
You just cancel it.
So all I have is
2x equals 1/3.
and I'll divide both sides by 2 to get x by itself. And what is half of 1/3?
1/6.
1/6. Question or stretching?
I kind of want to put that into the
Question.
calculator.
How did you get to 7 1/3?
Wait, how do you change the
Okay.
base?
She's got a question. When you raise a number to a fractional exponent, the bottom number is the index. So if I have a cube root, the 3 is my denominator. I've got to have something in the top. You know? It's that unseen 1 that we talked about, right? We talked about it a while ago. There's a 1 there. This is the cube root of 7 to the 1st power. So that 1 is my power. So it's right there. And the 3 is my index. It's down there. Yeah. What was your question?
How do you change the baseline law?
We're not there right now. I understand. I'm not there yet. Any other questions on this?
That's not.
Glad you're here today. You're always good for asking questions if I wanted to ask. I appreciate you. I don't care about you. Okay, so here we have a graph of 2 inverses because we have an exponential and its inverse, which is a logarithm. And if you'll notice that red and blue graph are in fact symmetric about some line. What line are they symmetric about?
Y equals X.
Y equals X.
Oh, I was.
Inverse functions are symmetric about the line y equals x. That's what I was trying to pull teeth about earlier today. I won't say that in the future because then Lonnie will cry.
Wait, can you please say that tomorrow? Please, I will pay you. I will.
It's like pulling teeth to get y'all to answer questions.
Please say that tomorrow.
You have to remind me.
You're
Oh,
cool.
say less. I will go home and
Okay.
study dentist jokes.
So logarithms and exponential functions are inverses of one another. Again, a and x must be positive, but a can't be 1. Nothing new on this slide. Check out the domain and the range. We spent time talking about exponential, and we said that in an exponential function, the domain is always
Real.
all real numbers, and the range is from 0 to infinity, right? The inverse. How do you find the inverse? You swap x and y. You swap the domain and the range. So for graphing a logarithm, the domain is 0 to infinity, and the range is all real numbers because x and y swapped. Okay. So we have several slides here, some notes, and some of it's repetitive. I'm going to the next slide now. A logarithmic function. If a is greater than 1, remember a has to be positive. If a is greater than 1, we're going to have an increasing function. When a is greater than 1, the function is always increasing. If a function is always increasing, then it must have an inverse, right? Okay. We have a vertical asymptote, which is the y-axis. Exponential functions have the x-axis as an asymptote. Well, if you swap x and y, can you see that now the y-axis is the asymptote? Okay? You all right? Okay. The points that they'll always pass, as we graph these, you're going to see me using the numbers -1, 0, and 1, just like I use on exponential functions. If a is between 0 and 1, the graph will be decreasing. We still have a vertical asymptote, which is the y-axis. The domain is still 0 to infinity, not including 0, and the range is still all reals. Okay, little drummer boy, stop it.
Are you doing this?
Yes.
I'm, like not realizing I'm doing it.
Yes, stop it.
I found out how to change the base.
All right, and here's another statement again. This is just saying the same thing I've been saying. All right, let's graph.
So exciting.
Graphing logarithms is not difficult. You are going to have to change your mindset on this, but it's not that big. We are going to graph, I'm going to change the f of x. We're going to graph y equals log base 1/2 of x.
Is there a reason you do it in cursive?
I always have.
Just
I don't want the L to look like a 1. I don't want the O to look like a 0. So, yeah, I guess. What's the base?
Half.
Power?
0? Oh, y.
No.
Y.
Yeah, why?
Thing?
X. Yeah, there's on the wrong side.
We have spent several years graphing. And when you're making a graph, you've always done the same thing. Solve for y, plug in values for x, and plot the points. Okay? That's what you've done. When you're graphing logarithms, we're not going to solve for y. Because when you solve for y, bless you, you've got this mess right here again. Okay? So when you're graphing logarithms, you're going to put it back to exponential form. You're going to solve for x. And you're going to plug in values for y.
So we are solving for x, just not for at first.
We're solving for x.
That's saying so.
But we're plugging in values for y. What is the range of a logarithmic function? What can y be?
We're saying about one and negative.
What can y be?
One.
Anything, right? We determined that the range of a logarithm was negative infinity to infinity. So y can be anything. That's why we want to plug y's in. We don't want to go with x because we got problems. Okay? I told you we want to try -1, 0, and 1. We're going to plot more points than that. But -1, 0, and 1 will get us an idea of what this graph is doing. Plug in -1 for y. 1/2 to the -1 power is 1/2 to the -1 power. The -1 power means
You flip it.
reciprocal.
It'll be 2, right?
It's just 2. 1/2 to the -1 power is just the reciprocal of 1/2, which is 2. I will plot the point 2, -1. Plug in 0. 1/2 to the 0 power is 1. I'll plot the point 1, 0. I will plug in 1. 1/2 to the 1 power is
1.5.
1/2. I will plot the point 1/2, 1. Can you see what the graph is doing? Remember, the domain is 0 to infinity, which means I don't want to plug any number smaller than 1 in. Okay, so remember, plugging in y's. I don't want to plug in a number smaller than 1 or bigger than 1 because all it's going to do is take off this way. I do want to see what's going on the other side. You know, does it come way down? Does it stop here? I don't know exactly. So this was a y value of -1. Let's plug in a y value of -2. I now have 1/2 to the -2 power. The negative means reciprocal. The reciprocal of 1/2 is 2. So I have 2 squared, which is 4. I'll plot the point 4, -2. Let's try -3. 1/2 to the -3rd power. The negative is reciprocal. So now I have 2 to the 3rd power, which is 8. Plot the point 8, -3. And if I plug in -4, I'm going to be off my graph. -4 is going to put me at 16. That's enough information to draw my curve. So this graph looks like something like this. How are we doing? We're sideways now?
Yes.
Earlier in the period, you were like, I like this. And now she's like, oh.
I hate graphing.
See if we can get through another one real quick. Base is 3.
3.
Power is,
Wow.
thing is,
X.
three to the -1 power,
Is
Negative.
1/3.
1/3. I'll plot the point, 1/3, -1. 3 to the 0 power,
1.
plot the point, 1, 0. 3 to the 1st power,
3.
About the 0.31. Do you have a good idea what this graph is doing?
Yeah, it looks like.
Oh,
the-
yes.
Down
it's
here
gonna
it's
go
coming up.
out and-
Yes.
Yeah.
Right? Okay, so it looks like I wanna plug some bigger Y values. I don't wanna plug any smaller Y values because it's getting closer and closer to the Y axis. But I do wanna plug in some bigger Y values. So let's go with
4.
2. 3 squared is 9.2. And we're about to be off the paper, right? So here's the graph. Is that better, Anna?
No,
No.
I just don't, like, where did the Y come from?
What?
F of X is Y.
Oh,
F of X is Y.
they're so confusing.
She said 1:30. I'll be there. It's